Hello everyone, I'm Chris Marcelino,
I'm Ryan Armstrong.
I'm Sean Chen.
And I'm Megan Flood.
and we are all bioengineering and chemical engineering majors at Miami University. Under the direction of Dr. Almquist, we have been researching the novel method of PFA removal using membrane-assisted liquid-liquid extraction known as perstraction.
Perfluoroalkyl substances, known as PFAs, with a specific type being perfluorooctanoic acid, known as PFOA, is one of many perfluoroalkylated compounds that remain persistent in the environment. PFAs can be found in many consumer products, like cookware, food packaging, and stain repellents and firefighting foams.
Since PFAs do not degrade naturally in the environment, they are present in drinking water and at a low level in the human body, which has been shown to have adverse health effects such as liver damage and eventually cancer. By researching a cheaper removal method from water than the current strategy of carbon absorption, we will have a positive impact on the planet, people, and prosperity.
Our methodology has been running individual experiments to find the best absorbent particle to add to the membrane and to find the best organic solvent for separation and diffusivity. For membrane testing, we measured PFOA concentration via conductance for various metal oxide and absorbent particle membranes. For our most successful absorbent particle, zinc oxide, we also modeled the absorption kinetics as PFOA uptake reached equilibrium, as you can see here. And to test diffusivity of alcohols through the membrane, mass of the membrane was recorded over a 24-hour period, and it was fit to the Krishna absorption model. And also, this is what our lab scale test system looks like. When you combine all the elements, there will be a membrane inside, and the PFOA and alcohol would go from one side to the other.
Shown in this picture are the membranes our team made with absorbent particles such as zinc oxide, copper oxide, manganese oxide, aluminum oxide, and iron oxide.
Shown in this illustration is the PFOA absorption per gram of membrane over time for PDMS membranes we made as shown in the previous picture. As the graph illustrates, both zinc oxide and copper oxide have the highest absorption of PFOA, while aluminum oxide and iron oxide had the lowest. A quick note, as of this moment we are unsure of whether the PFOA is being absorbed into the membrane or just sitting on the surface. Understanding this will require further testing in the future. From our data collected, several additional questions can also be asked, such as, what is the chemical interaction occurring between the absorbent particles and the PDMS? Additionally, is the size of the particles a contributing factor to PFOA uptake?
This picture is showing our setup for experiments concerning the solubility and diffusivity of PDMS membranes in differing solvents.
Each membrane had its diffusivity and solubility tested in butanol, octanol, and hexanol with water used as a control. A graph was made of the butanol data where the Krishna absorption model was used to calculate the solid line, which was then used to determine the diffusivity. This process was repeated for the other solvents. Of these solvents, butanol had the highest solubility and lowest diffusivity. Knowing this, we will be looking into other, shorter chain alcohol solvents in the future.
Finally, we examined the absorption kinetics of the best absorbent particle in the membranes and compared the zinc oxide kinetics to plain PDMS membranes of various sizes. Unsurprisingly, zinc oxide absorbed much more PFOA per mass of membrane, more than 9 times as much as a PDMS membrane when they both reach equilibrium. But another interesting result is that the constant, K, for both the pseudo first-order kinetic models increases with the increasing mass of membrane as seen here. This leads to questions about how much surface area, distance between PFOA and membrane material, and mass transfer limitations in the water impacted how much PFOA was taken up by the membranes. And further experimentation of this is planned for the future, as well as examining different masses of particles within the membrane and adding agitation. Thank you so much for listening to our presentation, and here are references for our work, and we look forward to continuing to research the novel method of perstraction.